Are you guys able to access the YouTube video links which I shared with you?
Yeah. It's working fine.
I think I have uploaded so far only the chef videos, right?
Yeah.
I'll upload all the previous ones as well, whatever we have covered so far. So only thing is in office also, like nowadays, the days are very busy for me. A new project has come up, because of which I'm not getting time in office at all. Okay, let this come up first.
Quite common. It's quite common. And Sharif, I'm sorry to ask, where you're working? Project?
Project as in, I typically, it depends on the project. It varies actually a lot for us because we are kind of DevOps architect team. So
Okay.
we get automation requests from different teams in our company. So sometimes we need only provisioning automation. So that we do with, and we have to kind of give the people the suggestion also, like which tool to use, which tool is better for them, and all those things. So obviously, I have an inclination towards Git and Jenkins and Chef, so I always use these things.
Okay.
So yeah, because we have all kinds of source control. We had Accurate, we have SPM, ClearCase, TFS. All those tools are being used. So I try to shift everyone to Git.
Okay.
Because according to me, Git is the best.
Yeah.
Obviously, sometimes people don't believe, and sometimes people don't, take my decision. So that time I have to go with them. It's taking some time. Let me show you if it is there on my system. See. Okay, typically this is the folder in Windows. C, and then Chef, and here there will be a cache folder, CACHE. Okay, it will be over here. And Linux, the typical location, if you have not changed it manually, it will be inside. This is okay, this is a new machine which I've created. I'm here to change the name of the machine. Host name is still the same, the default one. There's a workstation, but the location of the machine I have. Okay, this machine is not yet bootstrapped, I think, so it will not have. Typically, it will have. This is the problem with CentOS, huh?
Yeah. It will be the same problem with me.
Yeah. All right, let me just start up what we are supposed to do today. This I already sent you guys.
In a real-time environment, mostly they use CentOS or?
Completely depends on the companies. CentOS is not used mostly because CentOS is a free version, right? It's not an enterprise one. So Red Hat or Ubuntu, that is the one most commonly used. In fact, Red Hat is the most popular one for all the servers and all these things, because Ubuntu has come recently, right? On the server side, Ubuntu started with typical desktop application, right? It had all the GUI and everything. So it first started as a desktop application, then it moved towards the server side. So enterprise environments, you have Red Hat is number one. Then you have SUSE servers also. SUSE is again a Debian-based operating system. It's kind of counterpart for Ubuntu for server side.
Oh, it's more like administration and networking side.
See, you need to know a lot of things. DevOps is actually kind of an ocean. So you need to know a lot of things. I think I told you guys, right? DevOps administrators or DevOps engineers are typically jack of all trades and master of one or two. That's how typically it works. So whichever field you are coming from, say from infrastructure or networking or testing, you will be master of that field, and then you need to know the rest of the things, right? Because in DevOps we are catering from right from the developing till the time of deployment and beyond, right? So the whole process we need to be aware of.
These tools are only a little bit small part. The rest of the things are very important, looks like.
Yeah, exactly. See, tools are there to help you automate things, right? They're kind of, instead of writing a whole bunch of scripts, you can use the tools and to automate and to, streamline your process. But eventually it's at the back end, your servers, your applications, that is more important. So you need to understand your application, you need to understand your deployment process, you need to understand your infrastructure before you can, automate it. That's very important. I don't have it actually as of now. Please see. I don't think Chef will get it. Yeah, it's not there. Right. So, okay, let's do something. Let's do a recap for you guys. So yesterday I was not able to show you the demonstrations, right? So this is a new, yes, this is the workstation which I have created. And let's quickly, and this is a new node which I had created. Okay, so let's see what is the IP address for this one, if there is at all one. Okay, not configured yet. Let me just quickly configure it. New node which I have configured. So I just take these two details. And let's make this, let's give it 40. Right. The only problem is now we have to reload the machine. All right, meanwhile, let's just start with what we were supposed to do today. I think resources we covered yesterday, right? We'll start with anatomy of chef run. So this typically tells us what exactly happens and a couple of more things along with that. Okay, when you run the chef client. Yesterday we saw running chef client, right? We do a sudo chef client to make the changes onto the node. So today we'll see what exactly happens at the backend when you run sudo chef client. Okay, let's start with that. I'll show you the things at the end. We'll just do a recap. So dissecting your first chef client run. We are typically talking about the first time when the chef client run happens, right? Yeah, so we will see all the steps which are taken by a chef client during a run, and we will see how exactly the authentication takes place in when the node tries to contact the chef server, and the steps, what exactly happens when the chef client run happens. It collects the details, right? It runs the cookbooks onto it. How exactly the resource collection happens. We'll see all those things. So we go to the node and we run chef client or sudo chef client. First step, what happens is the moment you start run chef client, there's something called build node. What happens is the node is being built. The node is being built. What we see is there is a term called OHI. I think it should be on the next screen. Yes, OHI is the utility. It's a profiler. Okay, we call this a profiler application, which is there for Chef as well, for Puppet as well. Or Chef, the profiler is named OHI. For Puppet, I don't recollect. Let me just quickly check it out. Let's ask Google Uncle. Profiler for Puppet. It's not exactly needed, but kind of good to know. Oh, okay. I think it's known as profiler only. Right. So that's called as profiler in Puppet. Okay. So the same thing. What is profiler in Puppet? The same thing in OHI is in Chef. OHI actually collects all the information about the node. So what happens is you have a Windows server or a Linux server which is acting as a node. It has got a lot of information. It has got a complete hardware details. It has got a type of CPU, RAM, hardware, hard disk. networking cards, types of processors, all those things are there, right? Storage devices. So it will collect all the information about all these components of that particular node, all the hardware details. Along with that, what kind of operating system is installed, what is a platform, what is a family, all those things. Then it will collect information about how many users, packages, all these things are installed on that, users and groups information. The software packages information, what kind of softwares are installed on that machine as of now. And it will create a list of it. That particular, this process is known as build mode. Okay, some of the examples given are node name, platform version. So these are just 2-3 things. It actually collects thousands of information. Okay, in fact, if I want to show you where exactly you can see that, you need to actually come to. Is it the chef one? Yes, it is. You just need to go to the node, any of the nodes you go. Okay, select your node, and at the bottom of the window, click on attributes. These are actually the information which are collected. Okay, when you run, this is all collected by OHI. Now, if you see here, you can find out the information about the network. You can find information about the kernel. You see the Linux kernel, which version of kernel it is, what is the version of, what is the machine type, what is the architecture level, which is the OS, all these things. Inside that, what are the modules? So each and every detail. Most of these details you actually will never need, but it will be still be there whenever you need it, and whichever detail you need to manipulate with. Okay, and it will have the IP addresses, it will have the MAC address, uptime, all these things will be collected. Yeah.
1 minute, Sherry. Sorry. Why every time for everything IP address is coming 10.0.2.15?
That is a default one in case of Vagrant, and that is why we create another NIC card and give out that IP address. If you, any of the Vagrant machine, if you go, let me show you one. Okay, we're not yet inside the machine, but let's go on Vagrant and such.
Even I did today one Oracle Linux one, and it's got the same IP.
Yes, as I said, in Vagrant, by default, that is the first default address which comes in. And if we, okay, we are on the nearest node now. If I do a if config now, if I'm not sure if you remember, guys, earlier when we did if config, it was giving only 2 options, 2 of the results, eth0 and lo. These were the only 2 options. Okay.
Yes.
Now
Yeah.
this one has been added, the one which we created, and it has got the IP address which I assigned. Okay, but the first one, eth0, is still the old IP. Okay, so eth0, if you know in Linux, you can assign multiple NIC cards, and each NIC card will be assigned represented by this ETH. So ETH0 is one NIC card, ETH1 is another NIC card, as per the networking terminology. Okay, and the first NIC card is always the default one, eth0 in Vagrant, and it will have this 10.2.15 address, and this is the second one, eth1. So this is the actual one which we are using for our purpose.
Yeah.
Okay, so that is why, since it takes the first IP address, I mean first one, it is giving you this information, right? 10.2.15, and that is the MAC address of that machine, that particular NIC card, right? So not only that, if you scroll down, you will have a lot of other information. As you can see, the packages, the host name, machine. In our case, host name, machine name, and FQDN, all 3 are the same for this machine. So that is why. Now, if you come over here, if you click on OHI version also gives you chef version it is giving you, right? Where you have all these chef files installed, all those things you can find over here. So in a nutshell, it gives you a huge amount of information. Okay, as I told you, it's thousands of lines of information is saved with the help of OHI, right? So this one is collected as the first step. The moment you run chef client without doing anything else, it will first collect information about the node locally, right? Once that is done, then it will go for the authentication mechanism. Okay, we will see authentication, how it happens in detail. First, let's understand the sudo chef client run, how it happens. So first, the moment you run chef client, build node happens. So basically, the OHI profiler creates all the, collects all the information from the node. Then the authentication process takes place, and the node authenticates with the chef server. That is with the help of PEM file. We'll see how the PEM file is generated and all those things just after finished filling in this particular details. So authentication happens. Then once the authentication is complete, the node actually syncs its cookbook with the chef server. So I told you, right, there is a local cached copy saved on each node. So that local copy will be /etc/chef in case of Linux, C /chef /dash. That will be in case of Windows. So it will go and check that the cached copy, which was copied during the earlier chef run, is it the same with the chef server, or it has been changed? When not this one, the local one, the chef server copy. If it has been changed, say you made some changes to your recipe or run list or the files, and then you uploaded the recipe or the cookbook to the server, or you simply changed the cookbook at all, right? So you had an Apache cookbook, you removed that cookbook from the run list, and you added some other cookbook in the run list of that node, right? So whatever changes you have done from the server side and from the workstation side, it will check. If there is any change, it will accordingly download those cookbooks in the cached copy. All right. If there is no change, it will not do anything at all. It will say up to date, no need to download anything, right? Then the next step comes. If you see here, it expanded run list recipes, right? So basically, whatever recipes and cookbooks that you have mentioned in the run list, it will sync with those. Then it will load all the cookbooks. When I say load the cookbooks, it will check. You remember the converge option yesterday we completed? We saw that. Just before converge, it actually creates a list of the cookbooks and recipes and resources, what exactly it is supposed to run. Okay. So during that process, this is a resource collection process, which we'll see in a little bit just after this one, how it happens. Then once it has got the list completed, that these are the recipes or these are the resources I have to run, and these are the actions I have to take in. For example, I have to install a package. I have to start this service. I have to create this file with so and so permissions, right? I have to create this user. Whatever is mentioned in the recipe, it will have that list available, and it will load those. It will create that list. It will have it. Okay, some 10 resources. 5 resources, 7 actions has to be taken. Once that is complete, it will actually take those effect. It will do those things one by one. It will execute the recipes onto itself, the node, right? And that step is known as converge, the converging part, right? Now we have, once the converging part is completed, we have two outcomes, possible outcomes. It will be a success or it will be a failure, right? If it was a success, then node.save. Node.save means the build object, which was collected initially. If you remember, it ran OHI during this process, right? And it collected all the hardware information, software information about the node, kept it locally. Just an important piece of information, guys, that information is saved in JSON format. Okay, this format, right? And in fact, I think I have an example also. This is a typical JSON file, right? The JSON typically works in key value attribute. So there will be a key and there will be a value for it. For example, server is the key. The name of the server is the value. IP address is the key, and the actual address which you are providing is a value. Something like, say, IP address colon the IP address. So you mentioned something like 172.168.1.1. So this is a typical JSON key value pair format, right? Similarly, you have server name. Okay, I'm sorry. Colon the actual name of the server. Say we'll take the common example which we always use, GitLab 1 or GitLab 2, right? So this is a typical JSON format, right? For the people who don't know, JSON is actually very similar to XML, but it is replacing XML in a lot of places. Okay, and JSON is kind of used heavily nowadays for all kinds of API calls and all other things. So, and even in Chef, most of the information is saved and used in JSON format. So yeah, coming back to the slides. So if it is successful, if the convergence was successful and there was no error, then it will give you those successful messages which we saw yesterday, that Chef run completed in so and so seconds, and 2 or 4 resources updated. Those kind of message, but after every Chef client, successful Chef client run, if it is successful, it will save that object. Okay, and it will, when we say save, that means it will give that object to the Chef server, and it will come over here, which we just saw. This information. So this node object was collected during the last Chef client run, and since it was successful, it has been uploaded. So whatever information you see on this screen, since this is being fetched from the server, right? We are accessing our Chef server. We are not accessing the nodes. So this information was saved the last successful run, after the last successful run of Chef. Okay. So basically, in this step, it is uploaded. In this step, it is uploaded to the Chef server, this information which has been collected during the build node step, the first step after Chef client. If it was a failure, if due to some reason Chef client run did not succeed, then you need to, this will throw an exception, and it will give you an error, and the node object will not be saved. So thus, it will not be given to the server. And I think Nani, when you were doing yesterday and you were getting that error message, that time it was throwing an error, and the node object was not being saved onto the. That is a typical example of convergence being failed. Right?
Yes.
I think notification handlers, typically what happens is, like, once you complete everything, it will give you all kinds of notifications what exactly went wrong, where to check for the problems, and you have that option, right, where it gives you as detailed as possible the messages, so that you can work on the error message and fix the problem. Right? So this typically is Chef run. This is again a very important workflow from the interview point of view. Even if you don't remember everything, at least the important steps you need to remember. Again, it's not exactly very complicated. See, first thing is OHI run, right? We just saw that OHI run has to be complete. After authentication, once authentication is done, Chef, all the cookbooks are synced. Once the cookbooks are synced, they are loaded. Once the loaded is converged, basically converge is equal to execution of those cookbooks and recipes and resources. If converge is successful, the node object is loaded to the Chef server with the help of node.save. If it is a failure, then exception is thrown along with the relevant error messages. Right? So just go through this workflow once or twice or thrice, and you will be comfortable, because it's very logical. The step is very logical. Right? So any confusion, any questions before I move further? Okay.
Sharik, I just want to know the, not on this one, I just want to know the terms which I'm using, like when I'm trying to explain you something. I just want the logical terms to be explained to you, like in case, like I'm just telling you machine and all the stuff. But apart from that, I want to tell exactly.
See, if I hear something, when you talking to me, and if I hear something and if I can make it better for you, I'll do that on the spot. If I tell you, okay, instead of this, you should tell it in this way. But apart from that, the more you learn, the more you read about these things, you will automatically get the right terminology. Okay. So
because in the interview point of view also, while explaining, the main terminology is important, because they will think that we will know something about.
Yes. See,
know something about DevOps, but the thing is, if you can't explain them properly in the terms.
Yes. Terminology is very important. There is no doubt about that. What you can do for all of you guys, all these slides which I'm sharing with you guys, these are, I think I told you, right? This is not something which I have created. For Chef, I found this to be very useful. The official slides from the Chef learning documents. There are documents which you get for as a Chef trainer. Okay, so this is available to everyone. Even you guys can go and download from Chef. Okay, so I'm using all the same slides. This was actually a very big 700 slides slideshow, 700 containing 700 different slides. What I have done, I have just segregated it from each as per each point and each topic. That's all I have done. But other than that, this is official chef slide, and this contains all the official terminology of chefs. So the more you go with the chef slides, the more you learn, and the more you use the right words for any technology. Okay. So moving forward, we understood the chef client run, how exactly it happens, what exactly goes through at the back end when you run this sudo chef client command. Continuing with that, we spoke about the authentication part, right? If I go back, this is step authentication. We told that after the build node is complete, the OHI, the OHI utility collects all the information. Then it goes to the chef server to authenticate. Right? So how the authentication takes place, we'll see here now. So chef server requires keys to authenticate, and the actual keys is used is the client.pem. All the nodes which you have already bootstrapped. In fact, let me show you over here. GitLab 2 is the one which we have bootstrapped, right? This is the workstation. This is GitLab 2. I think we can just do a SSH. This is done. Yes. It's coming. It's a little slow, guys. So I'll show you. Basically, it means the client.pem file and validation.pem file. These are the two files. Can you guys tell me where do you get this validation.pem file? Any idea?
Chef client.
In chef repo.
Oh.
Okay. What is it?
Cookbook.
No, .chef folder.
Yes, .chef folder you get. But only difference is in .chef folder, the name is something like this. Something like whatever organization you name you give. Say I gave my organization Perceptor, right? Perceptor hyphen validator. In fact, the same name you see when you do a knife client list as well. Same name you get. Is this a workstation? Just GitLab. Okay, so let me just show you that where exactly that file is. So I go to cd etc chef, and if I do a ll, if you see here, client.pem, this is the file we are talking about. So this file is needed for authentication. Every time when I run a chef client, sudo chef client, after the boot, after the node object is created, it authenticates chef server with this file. If this file is not present, authentication will not happen. Okay, and yeah, so when we run that command, knife client list, it gives us that as our workstation. So basically, that is a validator file. So this file, .pem file, is actually present inside your .chef directory. What happens is during the bootstrap process, when you are bootstrapping the machine, it actually gets converted. First of all, it will copy. Chef will copy this file onto the node inside etc chef again, but it will change the name to validation.pem, right? So the file remains the same, the name gets changed. Okay. Now, yeah, if you see here, perceptor.validator, hyphen validator, the same name, just add .pem at the end of it. This is what you get. And okay, here it is. So now let's see how these are used. There's an important difference between these two files actually. So let's see how. When you do the authentication, when first time chef node tries to authenticate with the chef server, it will go and check whether this file is present or not. Okay, if the file is present, it will simply check. Chef server will check its own copy of the client.pem file, and it will compare the file, the content, the key with the client.pem file on the node. If the two matches, the authentication is complete. However, if the file is not present on the chef server, that will typically happen. Sorry, not on the chef server, rather on the chef workstation node on which you're trying to run sudo chef client. Obviously, for the first time, the file will not be there. I told you, right, during bootstrapping process, what happens? Org-validator gets converted to validation.pem file, right? So, this will not happen, okay? This portion will not be there. File is not present. Next, what will happen? It will go and check etc chef validation.pem. This file is present or not. So if you see, we're talking about this file, which has been created during the bootstrapping process of the node. Okay, it will check that file is present. It will compare that file. Again, if that file is not present, then it's an error message. Then something is wrong with the bootstrapping process. Okay, so you need to check and then need to fix it. It will be present on the node because of the bootstrapping process. So then you just need to go to that location. What will happen? Validation.pem file will be again compared with the file there on the server. It will identify. It will create a API client request. What will happen? Chef server will check this validation.pem file. It will see that the file is correct. This file is the one which is the organization validated file is the same as the validation.pem. So it will see that this is the right organization which I'm trying to authenticate. It will create a client.pem file for this node for the first time. Okay. Once that is done, it will keep a copy to itself on the chef server, and it will copy one file to the location. And again, the location is this one. Once again, etc. It will be like this. /etc/chef client.pem. So now this file will be present. It will check with the server and it will complete the authentication process. Right. So this part is again important to understand. This is one of the interview questions, right? How the authentication takes place when you run the sudo chef client, right? This is the step. This is the workflow which you need to explain, right? What is the importance of validation.pem file and what is the importance of client.pem? Okay. Any confusion, guys? Any doubts?
No, it's okay.
Okay. Just go through it again. It should be absolutely clear. Today's class, these are all the important concepts that chef client run, what exactly happens at the backend. It's an interview question. Authentication, how it happens. This is again an interview question. You need to be absolutely clear with the process. The next step, if you're going through the resource collection process, that is also an interview question. Okay. So today we don't have much labs. It's mostly the concepts we are going to cover. What happens in the backend? That is what we are going to see. So yeah, that takes us to the important third point, which is the resource collection. What exactly happens when we talk in this system? Load cookbook and converge. So load cookbook and converge. What exactly happens in these steps? Okay, this is what we are going to see. So during the compile phase, right? What happens when you do a chef client? It collects all the recipes, it syncs all the cookbooks, then it loads all cookbooks from the run list, okay? And then it reads each recipe to build the resource collection. During the execution phase, chef takes the resource collection, and for each resource, it will check if the resource is in the required state or not. If it is in the required state, do nothing. If no, bring resource in line with required state, right? Move on to the next resource. That is how this is the typical flow, how it happens. Let's see that example with the recipe which we created in the last class. We had a package HTTP install, then we had a cookbook file to be created, and then we had a service to be enabled and started onto the node, right? So on the left hand side, we have the recipe. On the right hand side, we see how exactly the resource collection happens. So it reads the first block of the resource. It collects package HTTP as a resource. Next block, cookbook underscore file, and the content of it, what exactly needs to be done. Service HTTPD, again, what needs to be done. So what happens now? It knows that it has got 3 resources, 1 recipe, 3 resources, 4 actions. It knows now. Now the execution takes place. First step, HTTPD package. Is it currently installed? If yes, do nothing. If no, install the package. Move to the next resource. Is where www.html index.html identical to cookbook version? So it checks actually 2 steps. First is to check whether the file exists or not. There might be a possibility that the file already exists. If yes, then check the content. If the content is same or different. Okay. Now for your information, guys, content checking, it doesn't read the content per se. Okay. What exactly happens? It checks the checksum of each file. Okay. It will check the checksum of the file which is there inside the cookbook, and it will check the checksum of the file which is there on the node. If the checksum matches, that means the file is identical. No need to do anything. If the checksum does not match, the content is different, overwrite the file with the content inside the cookbook file. Right? So once again, if it is identical, do nothing. If it is not identical, copy the index file into place. So wherever it is required. In our case, it is www.html index.html is the file. Does index.html have correct permissions? So once again, in here we have one more option. So in total, we have more number of actions now. We have mentioned mode as 0644 as well, right? If it has got the correct permissions, do nothing. If no, set permissions to 0644. Move on to the next resource. Service, HTTPD. Is it enabled to start on boot? If yes, do nothing. If no, enable HTTPD to start on boot. In Linux, we do it with the help of checkconfig command. I think I told you guys yesterday, right? Checkconfig is the command. Checkconfig, service name on. If you do, it will be enabled at the boot time. Move on to the next action, which is again the service resource, but the action is a start this time. So is the service HTTPD currently started? If yes, do nothing. If no, start the service. So this is the flow, how it happens. This is the flow, how it works, right? And yes, I think we saw yesterday also, and today also we are iterating the same thing. Recipes and resources, when the run list is happening, the order of the recipe and order of the resource actually matters. Okay, so if you have a run list, say for example, we have a run list, say for one, we have something called recipe, say NTP, right? Then we have recipe Apache, and then we have recipe, say RPM, any name you can use, right? And if I copy these things, so this is the run list. This is run list A, and we will call this run list B. Let's call this like this. Okay. If we copy it now, if I do this, we have just changed the order. Okay. Run list A is not equal to run list B. Okay. Run list A is different. Run list B is different. This is all I want to say when I say order matters. So in which order you are running having the recipes, that matters. Inside the recipes, what is the order of the resources, that also matters. As we saw in the last class, we have, say for example, we have these 3 resources inside the recipe. This is different, and if I put this before this, if I do like this, this also is a different recipe, different from the earlier one, because the resource order is different now, right? So recipes are executed in the order they appear in the run list. So I think, for example, which I showed you just a while ago, this one, if I come out, yes. So in this one, run list A, recipes will be executed in the order NTP, then Apache, then RPM. And in run list B, the recipes will be executed in the order Apache, NTP, and RPM. So these 2 are different orders. And outputs again might not necessarily be the same, the outcomes of each list, right? So that is why the order is important. These recipes are invoked in the following order. So once again, the earlier example, this one, we saw in a single recipe. Single recipe, multiple resources, execution steps. We have 3 recipes now, and each recipe will have some resources. So in that case, how it happens? So first recipe, resource collection. This is the first recipe. So all the, see, if you have package resource, template resource, and service resource, they will be collected here in the resource collection step. Recipe 2, we have OpenSSH, again 1, 2, and 3 resources. All these 3 resources are again appended to the earlier list. Okay. Then we have third recipe, which is HTTPD, again 3 resources appended to the existing resource collection, resource list. So now overall we have, this is the execution list. This is the resource collection list, and this is how it will be executed in the execution phase order, right? Yes, one important point to note is that you can actually write plain Ruby scripts in the recipes. Okay, as you can see here, we have in bracket, percentage W, and then this one. This is a typical Ruby command. This is actually doing for each do. There's actually 3 different sites available, sites enabled, and mods available. Dot each. For each, we are creating a directory and we are giving the command. So this is a typical Ruby block. Okay. Important point to understand is that in Ruby block, if there is any Ruby block, that is executed right at the top. It is executed at the compile time itself. Okay, and chef DSL is executed in the execution phase, right? So you see here, resource collection is happening. Again, once again, what will happen? It will have 3 directories created as per the name, right? Dot each. So this is what is happening here. So what I mean to say is, let's say we have a, let's understand in this example, we have a Ruby block right at the start. Okay, say that is there, right? And we have a Ruby block somewhere here. Okay, this is a Ruby block. Some Ruby script or some Ruby commands which are there without any resource. In both the cases, this one there is no confusion, right? First, the Ruby block will take place. This will take get executed, and then these 3 resources. Even in this case, this will come at the top. This will from here. It will come over here. Okay, it will come at the top during when the resource collection phase happens. It will be executed in this order. Okay, so it doesn't make a difference if you put the Ruby block here or if you put the Ruby block here. It's all the same thing. So coming back to the slide, if you see here, this is very important. Plain Ruby is executed in the compile phase. Chef DSL is executed in the execute phase. For now, you will not see this option much, and you might not face any problem because of this. But I had a situation. I mean, in our team, while we were working on one particular project, we had this problem. What was happening was we had a specific Ruby syntax to search something on the Chef server, and then we were using that as an input for another resource which we had written for some purpose. So what was happening? Sorry, it was the other way around. We had a resource collection. There was a resource. There was an output. We were using the search command. There was an output which was supposed to be given to the Ruby block. But what was happening? Ruby block was every time it was getting executed for the first time without any input, because the input is there from the resource collection, right? It was failing every time. So then we had to edit the recipe in order to work with it, right? So just important thing to know that order matters in resource collection. And the same thing is recited again if you have recipe 1, recipe 2, recipe 3, and inside you have actions. So this will be the order in which it will be collected and executed, right? So that completes the this particular slideshow, and these are the questions which you should be comfortable with by now. Just take a look and let me know if you have anything to discuss. And once this is done, I'll show you the bootstrapping process what we were doing before. So typically 3 things which we have covered today. First is what exactly happens at the backend when you run Chef client, what goes on behind the scenes, what exactly goes on behind the scenes, how authentication takes place in Chef when a Chef node tries to authenticate to the Chef server, and then how resource collection happens in Chef, right? Whenever you run a recipe or a run list, how exactly the resource collection happens. And as we saw that the order is a very important in resource collection and execution. If not now, we might have questions later on. So you can always come back as always. So let me just complete this portion. I think we have get to. All right. So let's bootstrap a node quickly to see if everything is working fine. We'll try that. This is a new node which I had created. Now I have the IP as well, which is this one. Let me just copy this. And I have created a Chef server, sorry, Chef workstation. Since yesterday's was broke, I had to create a new one. And this is the one I have. So what I do now, in order to bootstrap the node, what I need to do is knife. First of all, just take a look, guys. I'm already inside the Chef repo folder. It is very important. You need to be inside the Chef repo folder, otherwise your knife command will not work, right? Because it cannot read the knife.rb file. If you want your knife command to run from, no, that will not work. Sorry. Knife bootstrap. First thing is FQDN. So FQDN, instead of FQDN, we'll give the IP address. -X username is vagrant. Capital P is for password, and password in our case again is vagrant because it's a vagrant machine. We want this to run as sudo. And we want to give a -node name. So -node name, -node, -name. The name we will give, what is the name of the machine? New node. Okay, let's give the same name. So new node. That's all you need to do. Okay, so hit enter. Let's see what happens. Now, as you can see, it is actually communicating with the Chef server. The communication was successful. It has created a node. Then it is actually trying to do a wget, but probably some network issues. It is not working. It's trying again and again. So if you see here, it has already identified that this is a Ubuntu machine and Ubuntu 12.0. Right? See, Ubuntu 12.0 has already identified it with the help of the OHI profile. So based on that, it is downloading the package for the Chef client machine. Because of some network issue, it is getting delayed. So let's see. Let me check if I can cover the node object as well. So it tells you, I think we have already seen knife node list, knife client list. These things we already seen. This is the command to see the nodes. It will show the basic details of the node. Okay. So basically, nodes are made up of attributes. Many are discovered automatically. So automatically are discovered with the help of OHI. And we can actually create custom attributes also. That we will see in the next video, next class actually. We'll see how exactly we create. We need to work with attributes. We have covered the most of the fundamental aspects of Chef. We need to cover a little bit more, and we'll see like a couple of more examples. Then it will be clear to you guys, right? And this is the typical way. We have already seen this one in the GUI of the Chef server, and this is how it collects all the information. This is the JSON notation, JSON file format, right? And yes, you can go on the node actually, and you can see that as well. So let me show you. This is the GitLab 2, right? So by that, type oh hi, and we do more or less again the same thing. So it should show me the oh hi attributes of this particular node, and let's see what has happened here. I think something has happened. No, trying. No, still trying. So as you can see here, it has got this, and it can keep on going. This is how you see oh hi on the node. Okay, I'll just type control C, and yeah, if you do knife node show node one hyphen, then it will. This is on the workstation. So remember, guys, any knife command you are running on the workstation, right? Right. So these are the different ways to give. I mean, basically these are all commands you can just practice, and then you can filter it as well, right? So knife node show node one hyphen a. You type FQDN, you give IP address, whatever search result you give. This is basically searching how we are finding it out, right? And this one you can. This is a search command. Knife search is again a command with the help. If you have a infrastructure and you want to see the FQDN for all the nodes, so this is how you see it. Let me show you. Let me just, if this command is complete, I can show you. This will actually give you in this format. So it will give you the node name and the FQDN. So in our case, GitLab 2, at the bottom, FQDN. Again, new node, FQDN. Like that will give in that format. Right. The search is basically used when you have when you want to. Basically, it is used in the recipes and the inside the resources when you want to give such that you need to find something and then work on those things. Say for example, you want to install a package only on Windows 2008 servers. Okay, you will give a search command to find platform as Windows and OSS 2008 R2, right, or 2008. If that matches the criteria, that node list will be collected. That node list you can install whatever you want to install, like that. So that is one typical use case for using the search command. So what is a node object? Node object is nothing but the initial what we saw, like the attributes oh hi collected. That is the node object. You see here. So which is eventually uploaded to the Chef server. So in our case, the attribute section which we see, this is the node object. This is what we are looking at as of now. This is the node object which is created by the oh hi, right? And we have two types of attributes. One is discovered automatically with the help of oh hi, and we can create attributes manually also for our purposes. Okay, so that we will see in the next class how we create attributes and how we work with them. Right? Attributes we can create at multiple levels: cookbooks at the cookbook level, at the role level, attribute file level, and we have something called attribute precedence as well. So we have different priorities for different attributes. Okay, so yeah. So what is a node attribute? So each variable or each property of node is an attribute, right? How do you display? So in GUI, you can go to just scroll, select a node and go to the bottom of the node, and you will see the attributes listed under the attributes tab. If you want to see it on the node, you can just type in on the node. You can type oh hi. It will give you all the attributes listing. On node on the workstation, if you want to see, you need to use this, right? Knife node show node name hyphen L. Hyphen L will give you all the attributes. And if you just use just knife node show node one, it will give you the basic attributes, some 8-10 attributes it will show you. Let's see if it is complete. Sorry, not Okay, it is completed. The screen was not getting refreshed. So as you can see, the chef client run finished, 0 resources updated because we don't have anything in the run list. If I do a knife no show, we have given new node, right? That is really. Let's see what does it give us. As you can see, the IP address again because of the eth0 it is collecting, so that is why it is giving the wrong IP address. Other than that, it is giving the platform. Run list and roles and recipes is currently empty. Let's try the same thing for the other node, which is GitLab 2, and I think that has got some run list, so it should show you. Yes, let's see. It has got a run list, recipe Apache test, and recipes are these one. Apache test is the cookbook name, and this is the recipe. So default recipe, that is the only one we have. Right? Platform is sent to a 6.7, so it gives you all the information about that, right? If I do a knife node list, it should show me both the nodes because I have 2 nodes now. And similarly, if I go to the GUI, still not there, so let's just refresh it. So now it has got another node as well. Once bootstrapping part is done, right? And yeah, this last check-in uptime is the when the server was last rebooted, and last check-in property. This is actually tells you when the last chef client run happened, because when the chef client run happens, that is the time when the node kind of contacts the chef server. That is the last contact when it was happened with the server. Right? In our case, this was just 5-6 minutes ago, so it's showing 6 minutes ago. GitLab 2 we have not connected, so it's only a day ago. So yesterday we did that, right? So if I go ahead, if I go to the GitLab node, there's a GitLab node, yes. And if I do so chef client, obviously I don't think there is any changes to be made because and we have not updated the recipe since, so it will not update anything. However, after this, we'll see a different message over there. On the last check-in should be a minute ago kind of communication. Once again, guys, when you start the sudo chef client, first thing happens is it collects the new object, then it authenticates, then it syncs the cookbook, then it resolves the cookbook, as you can see, synchronizing is happening. Then
Sharik, I can't listen.
Yeah, it was. It's pretty.
okay. Is it better now? Can you hear me now? Hello?
It's good. It's okay.
Okay.
It's okay. Yeah.
So as I was telling, I just wanted to repeat the chef client run. As you can see here, the moment you run chef client run, it will first collect the node object, right, with the help of OHI. Then it will go ahead and authenticate with the chef server. Once authentication is complete, it will check which are the cookbooks in my run list, right? So it sees only Apache test. It will synchronize the cookbooks. It will see if there is any changes made to the cookbook. Right. Once that is done, it will compile those cookbooks. So when we say compile, it is creating that resource collection step is happening. Right. Once that is done, it will convert. It says converging 3 resources. Right? So converting means taking a step, executing those things. So as of now, it is on install. So obviously, it doesn't need to install because so far as I remember, we had done it yesterday. So at the end, it should just show the message that nothing to do up to date for all the resources. And I think the authentication part is complete. So now if I go ahead and refresh here.
Question. I want to see what I have written in like a cookbook using this one, like GitLab 2. How can I do that?
Yeah, etc chef cache you need to go to. Not here, it's going on. So let me show you the other one, the new one which we have just done. That is again bootstrap, right? So we now can go to ct etc chef, and if I do LL, as of now nothing is there. Or maybe if I have no, I think so, right? Yes. Okay, first one. Let this just complete. I'll show you over here.
Yeah.
Okay, it should be inside that folder. Folder called cache, CACHE. And if you go inside cache, you will have cookbooks. Cookbooks, right? That is why it's showing. Or is it done here also? Oh, I typed. It failed because I did a control C, because you guys anyways have seen other things. So let's go to cd etc chef to LL. Still not there. Maybe I'm getting confused. Let me just check. Cookbook location. Or ship mode. Okay, guys, I'll check and let you know. I'll check because
Okay.
I have it listed somewhere. So probably I'm just getting confused with the location. Basically,
Okay.
it's a copy on itself as well, right? That is how it actually. Let me check if it is there in the. Because that syncing time it tells you. Oh, okay, where cache. Let's see if it is there. CD where cache.
How do we learn?
Should have been there. I don't know. Cache. Where chef cache. Okay. All right. Here it is. So inside this, you have this cookbook folder. And in here, whatever cookbooks you have assigned for this particular node, only those cookbooks will be. Okay? That's an important point. You might have 10, 15 cookbooks on your system, but this node will have only the cookbooks which you have assigned to this, whichever is there in the run list. All right. So now if you can go inside, say I want to check Apache test. Okay, I go inside. I say do a cat. The structure will still will be exactly the same one once you are inside the cookbooks folder. So cat recipes default RP. Okay. Yeah. So this is what you have given them. Right?
And the code.
This is the code, right? This is the code you
No,
have.
no, the code. I'm asking like a HTML file. What I've written like.
Okay, that will be the files, right? So you have that will be inside files.
So basically the same architecture what you are doing in the workstation. You need to go into site
inside the cookbooks. You have the same location. I mean, once you are inside the cookbook, the hierarchy is exactly the same.
Okay, then it's okay. Yeah, no, I understood.
Right. So you have index 1 and index 2. So I'll write index 1. Let's see. Okay, so it's not obviously. Sudo cat. I'll do. See. Right. You can see the content there also.
Yeah, understood.
So yes, we completed the node object and we saw the authentication process and we saw the resource collection process. So we are through with most of the fundamental things. Now we'll complete the attributes part next week and the data maps. These are the two important things we can study. We'll take a look at roles and environments as well, what exactly these things are and how we work with them. So that will complete most of the chef components which we have. And then the next week after that, we'll see the Jenkins and Docker, and that will complete the course what we have. So I think we are almost halfway. in our course, and now you should have a much better understanding of things, how exactly things happen in DevOps. Right? You will get a much clearer picture once we work on Jenkins. Once we create, a pipeline starting from Git to Chef and to Jenkins, and then deploy things onto somewhere. Right? We'll see a couple of scenarios. We'll see 2-3 fundamental scenarios, how to deploy and how to check in from the source code. All those things we'll see. So that is again for the last week, and then we will cover Docker. Which will be, again, it's a completely different technology, completely independent, but again, it's one of the most, fast-paced technologies happening at the moment. A lot of things are happening in the Docker ecosystem.
Sharik, can I request you something?
Yeah, go ahead.